Right, today we move to the chapter 9. Actually, chapter 9 is the application of energy. So, for this chapter 9, the general one, we will apply the concept of KE. Okay, so 1 over 2 mv square. And also, we will apply the concept of PE. So, general one will be mgh. Right. So these two are the mechanical energy that we will talk about in these chapters, and also we will have work done. Okay, this work done, we have we may have few possible situation. Okay, so the work done, I remove this part. Work done you can be have a few part. Okay, for example, resistance. Work done by resistance. Work done by the friction, work done by the engine, and work done by some external force. Okay, so this work done, as we discussed in the previous chapters, the work done that you need to expense, right? So you need to use to overcome, let's say, resistance, friction. This one you will use to overcome all these kind of resistance in order to move. So this kind of situation you will have negative work done. Okay, and if the force that is applied to a body, let's say pushing force, or maybe the force that generate by the engine, so-called driving force. Okay, so these two we will consider the energy put on the particle. So when the energy put on the particle, we consider this are the positive work done. Okay, so you need to differentiate this type two type of work done. One is you expense in order to overcome something that resists you, for example resistance, friction, all this negative work done. Okay, so if I put some, let's say I put some charge on the battery. Okay, so external power go inside the body, we consider positive work done. Or maybe we use the combustion engine generate a speed for a car. This one we call positive driving force. So you need to differentiate these two, because once you have able to differentiate this thing, you will use it in the conservation of energy equation. But along this way, you will see some of the equation that given in the notes. The notes is a general statement by the textbook, or general statement by any reference book. But normally I will prefer student to be flexible to use the conservation energy. Don't go and memorize, because you memorize, when the question change a bit, then you can't analyze the question, because the equation that given in the textbook or reference book is fixed, but they are not flexible, but the question is flexible, so you will find difficulty when you apply to the real scenario. So let's go for a very basic question. You will see that actually you use a very simple logical thinking, you can do the question under these chapters, right? uh, Note that you will not go for exam. Okay, I mean the final exam for paper 4, right? As I mentioned, you will go for exam for mathematics paper. You will go for paper 1, paper 3, paper 5, and paper 6. And I think a college already decided, for the next semester you will go for the exam for paper 1 and paper 5. Paper 1 means pure maths 1 and stat 1 for next semester. And at the last semester of your A level, you will go for 6 papers, including 4 papers from the uh, further mathematics. So this one I think solve some of your worries about your application of your how to say, your Singapore application, right? So next semester you will go for a final exam for 2 papers only, right? Please remember that. And but you have no choice. The assessment 2 and assessment 3, you will need go for both paper 4 and paper 3. Sorry, paper 5 and paper 4 and paper 6, right? So mechanics and stat 2 you also have, will be included in your assessment 2 and 3. So based on the current plan, most probably your assessment 2 and 3 will be due in the same week, right? It will be due in the same week. I think will be due in June at the same week. So I think we have still a lot of time. I will catch some time to do the revision, right? Okay, never mind. We go for question 1 first. Okay, question 1. Question 1. A boy use a constant force of 250 Newton to push a box of a mass 20 kg, a distance of 4 meters in a curved path across a horizontal floor. The box start from rest. Find the final speed of the box. So for this question, normally I will use a simple way to analyze. Let's say this is before, this is after. Okay, before what you have, the box start from rest, so KE equal to 0. Okay, after you need to find, so KE will be 1 over 2 mv square, right? 1 over 2 mv square. Wow, don't know how much lah. Okay, once we have these two, then we see, do we have PE or not? This one no PE because across the horizontal flow you no need to write. But you need to, you have a force to push the box, so you put an external force on the box. So this is a work done by external force, so it's equal to 250 times 4. So you should have 1000 in here. Okay, so I put the work done at the before because along the way, okay, you put the force along the way, so until they reach to the final destination. So I don't put at the end, right? I put the before. Okay, so once you have this, check you still have any others energy that involved or not. If not, then you can form the net force equation. So all the before to the left hand side, all the after at the right hand side. So for the left hand side, 0, KE 0, plus the external force that put on the body. Okay, any more? Left hand side, no more, right? If no more, then you put at the left hand side equal to the left hand side. Left hand side you only have 1 over 2 mv square. Okay, so you see that this equation actually is the conservation of energy equation. Okay, so once you have this, you can have a V equal to 1000 times 2 over m. M is 20 kg. 20 kg. So you should get V equal to 10 for this question. 10 meter per second. 10 meter per second. Right? So simple, right? Before and after. Okay, B. When the coefficient of friction between the floor and the box is 0.12. Okay, same things. Now everything are same. Okay, the KE for before and after are same. Work done before are same. But now you have a friction that you need to overcome. So if you need to overcome the friction, so this one the part 1 is the same, so I remove first. So if you have a friction that you need to overcome, so I put at the before. Okay, before here. So work done that you need to overcome is equal to 0.12 coefficient of friction, and times 200 times 4, right? So you will have 96 joule. This this energy is for you to overcome the friction. You need to expand. So you already expand mean you already give to somebody, give out. Okay, so you can form a new equation, conservation energy. So Ke0 1000, and 1000 is the work done on the body, so you have a positive. And don't forget, this is the force that you expend in order to overcome the friction, right? So negative. This is for the left hand side. So for the right hand side, what you have once you reach to the destination, so you only have 1 over 2 mv squared. Okay, so for this question, once you solve, you will have v equal to square root of 904 times 2 over 20. So you should get v equal to 9.51 meter per second. Right, so this is for question 1. So a simple before and after, what happened? Okay, so all the expenses, okay, all the additional for energy we will put at the left hand side. Okay, but you need to verify which one is plus, which one is minus. Okay, so we move to question 2. For question 2, a ball of mass 0.05 kg is thrown vertically upwards with an initial speed of u, rise through a distance of 1.5 meter, and then fall through a 2.5 meter before hitting the floor. It hits the floor with a speed of v, and throughout the motion air resistance of 0.1 x on the ball. Calculate the initial u and the final speed of v. Okay, same things for this question. Because the ball is go up to the maximum and drop down again, so for us to calculate the u, we will consider the first part. Okay, the first part will be from before it's up, okay, starting point, and to the maximum point, to the maximum height. Okay, then the thing drop down again, so we consider these 2 points first. So before and after, so at initial situation, ke, the initial speed 1 over 2 mu squared. Normally we use to the initial. Okay, so and the ball reach to the maximum height, ke equals 0, because maximum height v equal to 0. And at the beginning, we assume that the throw from a reference point P equal to 0. Okay, and after a while, this item reached to the maximum height, 10 and 1.5. Okay, so then you have this side, your P is 0.75. Okay, but don't forget, you need to overcome the resistance. Okay, so the work done by the resistance to overcome the resistance is 0.01 times 1.5 meter. So you have 0.015 joule in order to overcome the resistance. So these are the energy that involved in the part 1. So now you can use this material to form the conservation energy equation. Right, I create first. So now I put the left hand side first, the kinetic energy. Okay, so you need to overcome the resistance, so negative. Overcome, spend out already. And left hand side no more, only ke and also the work done by the resistance. Okay, work done to overcome the resistance. And right hand side you have what? Ke equal to 0. Then you only have the PE, so 0.75. And you will simplify u equal to 0.765 times 2 over 0.05. So you will have 5.53 meter per second. Okay, so your initial speed is 5.53. So now you need to use this 5.53, okay, in order to find the final speed of the item. So same things I divided by two parts. So from the maximum point, okay, to the floor. So at maximum point, Ke equal to 0. Okay, and you have a PE equal to 0.05 times 10 times 2.5. Oh, this part you don't need to use the 5.53. You just because you need to find the final velocity, you just use the Ke equals 0 at the maximum point. It's okay already. And don't forget the work done by the to overcome the resistance. You have 0.01 times 2.5, right? And another side, at the floor area, Ke equal to 1 over 2 mv squared, and PE equal to 0 because they reach to the floor. Okay, so these are the items that you need in order to form the equation. Okay, now we form the equation. So you have PE at the beginning, and you need to overcome the resistance. And at the end you have a velocity because you don't have any Ke anymore. You don't have any PE anymore because you already reached to the floor. So now you can find your V. Times 2 over 0.05. Right, so you will get 7 meter per second. This is the final speed that you will use. You will achieve. Okay, when the ball approach to the floor. Okay, so this is for question 2. For question 3, okay, question 3. Woman snowboard down a hill of varying gradient. The mass of woman and her snowboard is 64 kg. She starts from rest at the top of the hill and accelerate under the gravity. Throughout the descent, the woman does not work to accelerate or decelerate the snowboard. So mean the thing will let the item slot down by itself. Okay, the average frictional force is 1.5 and all other resistance forces are negligible. The snowboarder reached to the bottom of the hill with a speed of 30, having traveled a distance of 500 meters in a zigzag route down the hill. Find the height of the hill, h meter. Okay, so for this question, same things we will put the before and after. Before, after. Okay. So at the beginning, start from rest, Ke equals 0. And PE will be the potential energy. It will be equal to mgh. Will be equal to 64, 10, and h. Okay, you can simplify as a 640 h. And the work done against the friction will be equal to 1.5, the frictional. Don't forget you have a 500 meter traveling, so 1.5 times 500 you have 750 joule for the work done to overcome the friction. Okay, for after, what you have Ke at the below. You have 1 over 2 times 64 times 30 square. So here you have 288,000 joule. And we reach the bottom of the hill, so PE equal to 0. Okay, so you can see that the work done along the way or overcome or add on we will put at the left hand side. So right hand side you only have KE and PE, right? So these are things that you need to consider. So once you have this, then you can form your conservation energy equation. So you have a 640H, the MGH, and minus 750. Okay, so this minus is because you need to spend to overcome the friction, and is equal to 288,000. Okay, so here we simplify, we can calculate the H. H will be equal to 462 meter. Okay, so these are things that you need to calculate the H, right? Simple, right? Okay, so now we proceed to question 4. Question 4. A box of mass mkg is initially at rest. It's slide down a smooth slope and the incline is 30 degrees to the horizontal. Find the speed of the box after sliding a distance of 3 meters. Okay, same things before and after. And before the thing slide from KE equal to 0 and PE equal to mgh. And the question never mentioned other work done that involved, so you can leave it. And another side, after you have KE equal to 1/2 V square, and reach to the bottom, PE equal to 0. Okay, the distance that you travel, you know, right? Okay, distance travel is 3 meters. Okay, and so that you can form mgh is equal to 1/2 mv square. Okay, so your v will be equal to square root of 20h. So this is the first part. So once you have this, you know that the height is equal to 3 sine 30, right? H 3 meter travel 30, 3 sine 30 will be equal to the h. So your v will be equal to square root of 30, and your v will be equal to 5.48 meter per second for this question 4. Okay, now we proceed to question 5. Okay, for question 5, a ball of mass 0.05 kg is thrown vertically upwards from a height of 1.5 meter above the ground. The ball rises through a height of 2 meter, reach to the maximum height of 3.5 meter. Okay, then use the conservation energy mechanical energy to find the initial speed of the ball. Okay, same things. Question 5 is set before, after. Okay, before what you have? You have a PE. Your PE is equal to 0.05 times 10 times 1.5. Okay, so simplify, you can simplify this one equals 0.75. Another side, what you have? Your P is 0.05 times 10 and times 3.5. Okay, here you will have 1.75 joule. Okay, these are the PE for before and after. Now we consider the KE. KE For initial situation, you don't know, so 1 over 2 mu square. And our maximum height in Ke is equal to 0 because V equal to 0. Right. So once you have these things, you don't have other work done that involve. So once you have these two, Ke and Pe, now you can form the equation 1 over 2 m u square plus mgh. Okay, then is equal to the right hand side. Right hand side only have mgh 1.75, so that you can simplify your equation in order to find the u. Your u should be equal to 6.32 meter per second. Okay, so this is your initial speed of the ball. Okay, right, now we move to question 6. Okay, question 6 a little bit different. Let us read the question first. Question 6. Okay, for question 6, a ball of mass 50 gram fall from a rest through a height of 80 cm, hits the ground and rebounds to the height of 30 cm. Find the mechanical energy loss in the motion from the start at the height of 80 cm to the end of the height of 30 cm. Okay, so the first part, when the ball fall from the 80 cm and reach to the ground and bounce up. Okay, so if there are no losing of energy, okay, when the ball start from 80 cm, the speed will be increased until hit on the ground and bounce back. If no energy loss, they will go back to 80 cm theoretically. Okay, but from the question, you find that actually after bounce back, you only can reach to the 30 cm, means the total energy already lost. So for this question, same things you can say before and after. Before, what you have? Start from rest, you have PE, right? You have PE is equal to 0.05 times 10 times 0.8. Okay, so this is your initial energy that you have. But after bounce back to the maximum height, the total energy that you have is 0.05 times 10, but now you only have 0.3 meter. Okay, so the energy loss will be equal to 0.05 times 10, 0.8 minus 0.3. Okay, so you should able to get 0.25 joule. This is the energy loss that for this question. So the energy loss to where? So most probably, the question never mentioned, most probably the ball may be hit on the ground. You have some contact on between the ball and the surface, and you may lost the energy as a hit, or maybe sound. We don't know, right? So this kind we call loss of energy. Okay, so the concept is the same before and after. So you see the total energy difference before and after, then you're able to find the loss of the energy. Okay, so this is for question 6. Question 7. A crane of max 50 kg slide across a rough horizontal floor. The crane has an initial speed of 3 meters per second and brought to rest by a friction. The distance traveled by the crane is 4 meters. Find the coefficient of friction between the floor and the crane. So same things. You set the energy that we have before and after. Okay, before we have what? Initially we have a Ke equal to 1 over 2. M is 50. V square, we have 3 square. Okay, and for after Ke, what you have? Equal to, stop, 0. And don't forget, for before, you have the work done. Work done to do what? To overcome the friction. So you have 500. Okay, 500 is the R, the normal contact force, 50 times 10. Then multiply the distance that you travel. Okay, so this is the work done to overcome the friction. So for this question, the question asks you to find, you still have one mu here. Okay, mu R times the distance. So this question asks you to find the mu. So now we form the conservation energy equation. Okay, so before what you have 1 over 2 53 square minus, because you need to overcome the friction, 4, and is equal to ke 0, everything stop 0. So you simplify, you have 2000 mu is equal to 225, and your mu will be equal to 0.1125. Right, so this is the coefficient of friction between the floor and the crane. Okay, so today we will stop at here, and next week we will continue the last part of the energy, right? So I already posted one question for you to solve as an assignment. Please remember to solve it and submit. Thank you.